Okay, so this is going to be the only meeting this week. I have to go to Kentucky. My dad's having a surgical procedure. Shouldn't be a big deal, but it's time consuming and all that. But I'll still be around via email. I'll still be able to Zoom, all that stuff. Take my computer with me. So it shouldn't be any real issue, except we're not meeting on Thursday. That's the real issue there. Um, so tonight I can talk about the homework that was just due on Sunday. If you haven't turned it in yet, you can go. I haven't graded it yet, so you can go ahead and turn that in up through tomorrow. I think most of you did anyway. Or we can talk about the new stuff if you like. Either one. So I'm open to suggestions as to what you want to talk
I don't know about Mary Beth and Jude, but I was having some trouble with the tests, formatting those from last week.
about. With okay, which one?
Well, all of them, I guess, but the rational,
Okay.
no, maybe it was the rectangle that had a for statement. And I just had, I know you gave us a lot of help in a video on the, I have to look back at what it was called, but.
The rational one. A lot of people have trouble with rational.
So either one of those would be great if that's all right with everyone else.
Yeah, I think so. What were you saying, Jude?
Said the rational one was the one that gave me issues too.
Gotcha. It was weird.
I looked at it and it was like it was a foreign language. I have no idea what I was doing on it.
It really is foreign. I think
This whole class is foreign to me.
I think Kim had sent me her version and I fixed hers. So I've got a semi-working. I didn't do the whole thing. But I can show you what I did with fixing hers.
Yeah, because that was my problem. I was like, with having the two rationals that you had to put in.
Yeah.
And I was like, I don't understand how to make this, like, call it. And that was my biggest issue. So when you sent me that, I was like, okay, and it worked.
Yep.
I just couldn't figure that out. And then I think I need some clarification on the static. Like when you had said like I had made stuff static.
Yeah.
I guess I'm not completely clear as to what that does.
Okay, if you're going to call something, just call it out of the blue, not attached to anything dot that. Then it's static. The GCD here is static, right? You're just going to call that. You're not going to say rational number dot GCD.
Okay.
Okay, so that's why you can do that. Okay.
Okay.
But so again, I think I've given you this code in my video before. So this is just the GCD, and I'm guessing it was an eyesight problem. She was having issues that she had a 1 instead of an I, and it was odd that it worked for the first one. That was the weirdest one. She had I think 2 and 4, and it worked, but then she had something else and it just didn't work, which is strange. But yeah, that was the issue. To catch that, I had to paste mine over and look at them side by side because I wasn't catching. So that was the first issue, and then I think I also showed you more or less what the simplify does. Okay.
Yeah.
The show fraction is pretty straightforward. It's just going to return that string. No big deal there. And again, all these are not static because you're going to say if you have a rational number R1, you're going to say R1.simplify or R1.showFraction. Okay. Or R1.show or R1.decimal, all those things. Okay. Where things get hairy is down here. That what we want to do, we don't want, and you probably could do this, but I don't think it was the way the book wanted. You were having issues. Rather than fix your issues, I went this way. This makes more sense to me. You want to be able to say, if we have R1 and R2, both rational numbers, I want to say R1 dot add fractions, parentheses, R2. Okay, that ties it.
Because I didn't actually do it the way you have it there.
Uh-huh.
I left it with R1 and R2.
Okay.
And it still worked.
Yeah, it's just a different thing. It depends on what you want to do. What we're moving toward is the ability to overload operators. So we can say just R1 plus R2. That's what we're getting. We're not there yet. I don't know if we'll get there this class, but that's a thing you can do. So by starting, we're doing it this way, where we're going to make it a non-static function, and we're going to say R1 dot adds fractions R2, and that would have worked. Okay, You can, if you want to make it static, that's okay too. I don't know that the problem said one way or the other, whether it said to make it a static one.
I don't remember.
Yeah, so either one, if it works, is okay. Okay, but then again, all we're doing here is, in my case, I'm attaching it to some fraction that I'm gonna call this, that is called this, that's how this works, okay? So I'm gonna check to see, again, this is Kim's code that I just modified. If the number I'm sending in, if its denominator is equal to the denominator of what's to the left of the period, okay? What means we have the same base already, we don't have to do anything. Okay, so we're going to, again, do this, a new number is going to be equal to R1 num plus this num. Okay, so we've got the same base already, so it's going to go ahead and do that. Then we're going to create a new rational. Again, I had to make it rational 1 because I already had a rational, but she called it just rational. So a new rational called R3, it's going to be based on this new numerator and then the denominator. Or this could be either one. This could be either this or the R1 because they're the same. Then we return that R3, okay? And that's the case where they have the same base already. No, you didn't really have to do that because even if they didn't have the same base, because you're going to simplify, even if they did have the same base, if you just did the else and no if, you can't do an else without if. If we'd have got rid of the if else, it would have overcomplicated by multiplying the denominators together even when it didn't need to, but it would have all came out in the washing. But this is cleaner. I like this better. Okay. So then this is the case where they don't have the same base. So we have to create this new base by multiplying the denominators of the R1 that's coming in, and the this refers to the one that's calling it. Okay. And then we just have to get the numerators and the new numerators for 1 and 2, where again, we have to multiply it by the denominator of the other one, okay? And then again, we're gonna get the new numerator by adding those together. And then we return this new R3 that has the new num and the new denom, okay? We return that R3, okay? So I didn't do the others, I just deleted those for the subtraction, all that. The same basic idea, okay? You can do them the same way. If you're having trouble, put them on paper, and work through what each one's equal to make sure that they're working. And do something like 1/2 plus 1/2. That's easy enough to do. Okay, so that's what I did to test it. And then as far as the test program goes, let them done this way. So I started off here with creating a fraction 1, it's 2/4, a fraction 2, which is 6/12. Okay, and then I'm printing out the fraction and the decimal for both of those, okay, which with the show fraction function and the decimal function for each of those two, okay. Then I'm simplifying both of those, printing them out again down here, okay. Then I'm creating a new rational 3, and I have to have a rational 3 to accept the result of the addition, okay. So I made it 1, 1, it could be anything, we're going to wipe it out, okay. So then this fraction 3 then is going to be equal to fraction 1 dot add fraction 2. Okay. Now the way that
Actually didn't do it. That I skipped step 20 by saying rational fraction 3 equals that.
yeah, that works.
I think it let me do it.
I assume yours looks like that as well.
I think I still had the fraction 1 dot add fractions.
Oh, okay.
It still worked.
Oh yeah, it's redundant, but yeah, that would work. This probably
Yeah,
works.
because I was like, this seems like a little bit much, but it worked, so I wasn't gonna question it.
No, if it works.
That was my big, for me, the issue was, it's not that I didn't understand what the process needed to be. Like, that part wasn't hard for me, but it was figuring out how to make the code, how to call it. I don't know. It just, especially with the two rationals.
Yeah.
It just didn't make any sense. And I figured it was something fairly simple, and it was.
Yeah.
I just didn't know what it was.
Being off with the typo basically hurt. It was hard to get anything working.
Well, and that too.
But then, you go through those and it simplifies them. I had them both be 1/2 again because I was testing, and it kept it as 2/2, which is interesting. I guess the GCD kind of fails there. That should have gone to 1, but I wouldn't worry about that at all. Okay, but So Barbie, Jude, what questions do you have after looking at the code?
Did you have to do an if else statement? Could you have done a series of methods?
Series of what?
Like just methods to add, divide. I didn't do an if else.
I just did that because it just,
I mean, mine didn't work, but
I don't think you absolutely have to. I just think it makes it more complicated, sort of, because
This works as well.
yeah, I mean, yeah, you don't have to. I just did that because in my brain it made sense that way. I was like, I was thinking like if I had to do this problem and the denominators were already equal, then I don't have to fix anything and I can just do it.
Yeah.
And so I did that case first, and then I was like, but if they're not the same, then I have to do this. But I think you could just do that.
Yes.
It's
could.
all gonna.
And then once you have this, I mean, this, so you don't need an if like a menu to choose what you're doing, because this is a class, right? We're not, the test class is where you pick, and you don't need to let them choose either. I mean, that could be a program where you ask them the numbers and whether they want to multiply or divide or whatever, but that wasn't what they were asking. So you would just have to do this next public rational one, or rational in most cases, and then subtract rational R1. And then you would do more or less the same thing, except you're subtracting and not. So in fact, subtract, if I'm not mistaken, looks exactly the same, except that's a minus sign, right? Isn't that the only difference?
I
and
think so.
One thing yours didn't do, Cam, is that you should call before you return it, you want to simplify it.
Oh yeah, I did that in the
In the test.
test. Yeah,
You could,
that
but
would have made more
this
sense.
this is more correct. This way you're
Yes.
not relying on them knowing that.
I
Okay.
didn't even think about doing it that way.
Yep.
I was just so happy it finally worked.
So, I mean, again, to do subtract, it's literally, you cut it or copy it, you don't cut it, you copy it, you paste it. You call this subtract or subfraction, whatever you want to call it. Change that, we're done. That's it. Okay.
I had thought about calling that like the R, well, I called mine R1 and R2 also, but then I thought about calling it R3, and then I ended up thinking like, are they gonna get confused? And then I ended up changing them so it was like, all of them had different names. So it was like the difference, the product, so I called like for each different answer.
I did that too.
But you don't have to. It's its own world, right?
Yeah, because it would only be running one.
Yes.
At a time.
These brackets, little braces, are like fences.
Mhm.
It's like Las Vegas. What happens in there stays in there, unless you return it. I mean, if you return it, it has effects in the outside world. And again, remember, if you send it in an array or something weird, it can have effects. But in general, the things you create here, the variables you declare in here, they don't go anywhere. Okay, so you can reuse the same ones. And by reusing the same ones, there's less mental work for you to remember what they're all called.
Yeah, and then I had originally made a simplify method, and then I don't know if I changed it to make it wrong, but I changed it so that the constructor simplified it. So anytime it called a this, it went ahead and simplified it.
Oh, that's interesting.
Is that wrong?
No, I mean, it's not. It depends on, so what that's doing is that when they create it, it's simplifying right away. That's not a bad idea. You would still need to simplify after your addition or subtraction or whatever. But yeah, that would avoid having in the code having to do this, right?
Yeah, because I kept thinking like, why should I have to simplify it for every single method?
Yeah.
After it adds or after it subtract. And so when
Did
I
it still-
changed it that way, it made it simpler, but then it also, I was like, maybe I did it wrong because I left out that method.
No, I mean, it shouldn't matter, but in the case of the addition, it's going to do the constructor here unless you combine that into one line. Maybe by combining it to one line, it's going to run the simplification. That's possible. But I would,
Well, they all worked right when I tried them.
okay, that's interesting. Yeah, and so if it
Because I
works,
would do,
that's good.
yeah, because when I returned it like as a, I ran it as integers.
Right.
And then returned it as a new rational. So it
Right.
like called this again.
Gotcha.
And so it simplified automatically.
Gotcha. Yeah, that works. Yeah, the more you can get rid of, the better, for sure.
So it's okay that I got rid of that one method?
Yep.
Okay.
Absolutely. So Barbie, Jude, more questions on this one or anybody else for that matter?
I think I see what I did. I'm going to go back and play with it just for my own peace of mind.
If it lets you resubmit, go ahead. I'm not going to grade these real harsh.
Okay,
But yeah, if you want to resubmit it, go ahead and give it a shot.
all right,
Can I
Until I
ask
grade it.
another-
Once I grade it, then I'm probably not going to go back unless there's a good reason to go back.
sure.
Can I ask a question as far as the test classes go?
Yes.
You had mentioned before, like, make sure you're testing every single thing.
Yep.
But what if one of the things you're testing if it tests more than one thing, do you have to test it individually too?
You don't unless I don't see it and take points off. Then you have to send me an email saying, dude, I tested that already.
Yeah, because for example, when I had on that program, when I'm calling them, it's like my method is using the get function. And so I didn't test the get function, but my method is using the get function. So it already is.
If I see that, that's good. But from a test, from a get all the points you can get point of view, if you test them all atomically on their own line, I'll for sure.
Right. Oh, okay.
So but if it's easier for me to grade, it's less likely to be a mistake. But if there's a mistake, you can show me that and I'll go back and correct it. But by putting, and to me, in my mind, when I'm looking at, whatever function I'm dealing, whatever method, not method, whatever class I'm dealing with, I'm going to go through, I'm going to test this one. I'm going to test this one. I'm going to, and I just click them off that way. So I'm not going to forget any. And so it's really clear. I mean, you don't put test programs out into the world ever. They're not useful functions. They're there just to test them all. So for that reason, I think it's just simpler. It's not wrong the way you're doing it, but I think you're less likely to forget something if you actually just test them all.
Yeah, because when I ended up changing that one for the simplification,
Uh-huh.
I had in my test class that it would call the original one and then also call the simplified version. But
Right.
then I realized once I had changed that, it wouldn't call the original one.
Right.
It would only call the simplified.
Gotcha.
So I took it out, because it only simplifies.
Right. I mean, that makes sense. And again, if it works, it works. That's the main thing,
Okay.
And again, if you look at how these things work, when you're creating a class, it's because you need to model something in the world. You're going to test it all. And then you're going to just file away that test program and then let other people use it. You'll put it as part of a package or whatever. Everything we use, the printf, the println, those are methods somebody wrote and tested, and they got added into the language. So almost everything's a method somewhere. And companies or organizations create their own libraries of functions that you can use, and that makes it easier on everybody that you can use code that's already been tested. But testing vigorously is a good thing. Okay. But yeah, when I've caught that, when I'm ready to take points off for not testing all the methods, I'm like, oh, well, that called that, so that must be, and then I take those points, I put them back on when I remember. And if you see me make a mistake, let me know. I mean, I am not perfect. No one is. So I don't always.
Tara, were you referring to something in particular? Was it like this program?
Yeah, this one is the one I was
Okay.
mentioning. That mine didn't call every single thing, but that's because some of my methods used those. So I didn't test
Okay.
them in the test program because the methods that I am testing use those other, use those other things. So I had left it out, but then I started second guessing myself about whether I should have done it separately or. just
Bottom
kinda
line, if it works, it works. You know, that's the good thing. And if I take off points and it works, then let me know. I don't always run the code because for whatever reason, it's a pain to run Java class files. I don't know why, it's just cumbersome. So I tend to read the code and I like you to have a class file because I know at least it compiled once on your system. I can look at the code and grade from there. But yeah, if I take off points and you think it's not legit, let me know. I am going to make mistakes, no question. Well,
I
let's-
don't want to take up too much class time, but could you just look at mine and tell me where I went wrong? I don't see a bunch of little flags, so I thought I was on the right track, but,
Yeah, let me let you share. Let's do it real quick. So I want to get on some other things, but we certainly can do
or you can just tell me when you grade it.
that. No, I don't mind doing that. Why is it not giving me the option? Oh, I have to quit sharing this. That's why I don't have the option. I can't share while you're sharing. Well, you can't share while I'm sharing. Okay,
Okay.
pop it up. We'll take a quick look.
Okay, well, I didn't do the if else. I just did a bunch of methods.
That should be,
And I
didn't
did
either.
use what you gave us to begin with.
Yeah.
And because you said that we needed to put the get and the set, the mutators and the accessors in there, so.
Yep.
I don't
Yep.
know if I'm
I don't
scrolling
know if you
down.
needed the mutators necessarily, but you know, it's not bad you put them in there.
Oh,
Okay, so the add. Okay, so you got numerator. Okay, where's your other number coming from on that? See, that's the issue you've got.
like I put it in the test, like I should have added the variables for it here.
Well, because you've got a rational. Oh, no, you're okay, because it's, yeah, I see where it's at. There should be I'm thinking there should be a this like on line 33, but it's working, so it must be okay because of the R dot. Okay, so you've got numerator. Yeah, I mean, as long as your formula is correct. So your new numerator is the numerator times R denominator plus. It looks okay.
I
Okay,
don't think your string, I don't think that's gonna return what you want it to.
is that line 60? Line,
50,
57,
it's going to return literally n divided by.
yeah.
okay.
So
So I
like the way
should
I
have
did it
put
was I
in
put,
and the quotations around the slash.
yeah, like it was like numerator plus
did
and then
it
the
that-
slash and then plus and then the
Yes.
denominator.
Okay, so numerator plus. Oh, I don't know how I got that out. Oh,
Yeah.
okay, sorry.
I like the question mark. We'll start a new form of math.
Okay, and then plus D and then get rid of that.
Yep.
Well, now I got a flag on that. What did I do?
You have to use the words numerator and denominator, I think, right? Isn't that how you did it?
Yeah, whatever you're
Well,
thinking.
I thought, when I got
Yeah,
n equals numerator, I thought I could use that way.
No,
No,
it's-
because you
what's it-
made those integers in the other ones, but you didn't do it down there, so you have to use.
Even though on lines 13 and 14, I had numerator equals to n, like a
that only
and
happens
denominator.
during the constructor. It's 8 and 9 you have to worry about. Lines 8 and line 9.
Okay. Okay,
Yeah, does she even need line 13 and 14?
That's the constructor, so yes.
Oh, yeah, okay. I was thinking
okay.
something different.
So numerator, denominator.
Yeah, you're pretty close on that. I don't know why it's not working, but it may be something fiddly with the formulas, but you know, it looks more or less okay.
Well, it could have been something screwy I did in the test.
Yeah.
So that was my issue, Barbie. And so what I had to do was in the test, I had to use this string one.
57.
Yeah. To
That may have-
actually, so I'd have to do like, fraction, like whatever I called it. Like once it added them together and it made a new thing and it simplified, then I had to, in the print statement, put fraction 3 or whatever to make it a string.
Am I naming them wrong then? Like in line 17, where I've got R dot numerator, am I?
Well, 10 and 11 don't really mean anything, right? Because you're not calling.
Well, I was
15
trying
is
to,
right.
let me go back to that question.
I mean, it's not wrong. It's just not really doing much.
Okay, yeah, I just didn't know. I was putting in stuff. Let's see.
But 15 and 16 should both work.
And you don't need line 17 because that's what the method that you just fixed, that's what that's for.
And the error it has is that you've got a capital N and a capital D. But she's right. All you have to do is say R dot
When
whatever.
I get rid of those variables though, 29 through 34.
Yeah, because that's a whole different issue. You need to declare those variables. That still wasn't going to give you results because you didn't. There are two things you have to do. When you say rational A, you're saying A is going to be irrational, but that's just a theoretical thing. You have to have that new rational to call the constructor and give it life, to give it a memory address. So you can go back and just copy line 12 into two new lines for an A and a B. And that'll be fine.
Okay,
But you have to have the whole thing. You can't just say rational A.
okay,
Okay. And that should fix that.
okay, I'm gonna,
And then 14, you just need whatever you called your print statement.
Where-
And
whatever
Barbie,
I have my-
I don't know if I don't know. That was another question I had, but I was just so happy it worked. But I like what you did in line 12. That's what I did for both of mine.
Mhm.
I just went ahead and set them up. I didn't ask them to put one in.
Right.
It's like,
But that's okay. I don't think the book said.
yeah, I mean, I thought about it because I was like, well, I guess you could set it up so that they do put it in.
Yeah, I mean,
But
this is a test, so you want it controlled. You don't want
Yeah.
to have to type in. I mean, I love when a new programmer gets a really cool interface and everything. Like, oh, look how cool this is, and they have to test it 50 times and they hate themselves. So yeah, just put it in the code, test it. Yeah.
so
like, you
I need to do, one of these for A and B if I'm going,
Yes.
okay.
yeah, just create them and then do everything down at the bottom. And you don't even need all the scanner and all that. I mean, I think technically you can do that, but why
Yes.
torture ourselves?
That's exactly correct. And I don't think you're using this
Um,
at all.
Can you say that? Well, I could probably just listen to it later. Kim, could you say that one more time?
About what? Say what? What'd
That
I
I
say?
didn't need what and why?
So you don't need, like, basically lines 20 through 29 you can get rid of because hang on. 21. Actually 20, you don't need 20 either.
Because you're not using them.
So like, so don't like, I was thinking like you were too, like that you're going to ask them to put in a numerator and a denominator and they're going to create it. And you can do that, but it didn't ask us to. So like what you have in line 11, right, where it hard codes it.
Yep.
Just do two of those. Create an A, create a B, or
Yeah, you
whatever
gotta, like,
letters.
You change 12 and 15 to be A and B. But delete all.
Okay. So just stick my variables back in?
So take out lines 20 through 29.
Yeah, hit delete from where you are. And on 12, you're saying R simplify. There's not an R yet. So make that an A.
Yeah, so yeah, make R into A,
Oh, okay, and I got you. Where I copied it, I
and
didn't.
then that one into B.
Yeah.
And then
Okay.
change the 5 and 10 to something different just so you can add them, and see if
Yeah,
it works.
Test it. Yeah.
Because they're all the same.
Oh, because I
I mean,
copied and pasted.
it'll still work.
Yeah.
But
I mean, it'll work, but
Yeah,
yeah, I mean,
Okay.
you need a comma.
commas.
Uh,
Don't forget commas, not divide.
Yeah, you gotta do a comma.
Oh, sorry. Yeah, I did that the first time and I went back to his example and figured out that, okay.
Then the other issue you have is on 33, it probably doesn't know how to print out a rational number. So 33 and all those, you need to put a dot, whatever your print function was.
Yeah.
So,
So, but you can take out line 22 to 27 also, because you're not asking.
right, exactly.
I thought if you put get and set in the program, you had to put them in your test.
I didn't put those in my rational program.
It need to be in your program. It
I
didn't,
mean,
ask-
not that
Say
you
that
can't
again?
do it, but
you didn't need to
you
have,
would need them if if you are asking for it, but it didn't ask us to do that, so I didn't do it.
I guess because we've been doing it with all the others. If we had,
that's
yeah,
my fault.
that's why.
As I said, you always need access to some mutators. That's not correct. That's a training wheel answer. This is the real bike. This is the big kid bike answer that we don't need this. Okay.
Okay, and then you said none of my print statements would work without a what?
It's whatever you called your print function in rational.java, the one we just fixed.
It's been a week, so I don't know.
So you called it string. So back in the other one,
Yeah, you probably can't
do it a dot string with the parentheses.
I don't think you can name it string. It's gonna complain. There's already a string function. Yeah, that's gonna cause problems. On 56, just call it print function. Go back to the rational Java.
Oh, 56.
Yeah, change the function name from string to print function, other string. That string's okay. Yeah,
Okay, I thought that was the,
just
okay.
call it print function or print fraction. Sorry.
Print fraction?
Yeah.
Okay.
Now go
Did I-
back to test. And then you can go to the A and say A dot print fraction.
Down on line 25.
At the very end. And that should be in your help.
How would I'm a little lost. I know y'all are telling me and I'm thankful, but
Then you
And then
open
put your parentheses. Print fraction and then the parentheses like this.
the function.
Like how you have the B on 27, 28, 29.
Yeah, you see, open.
You have to have the two parentheses like this, Barbie.
Yeah, for a method.
yeah, okay. You mean on my,
After
After,
fraction, open, close parenthesis.
and then A inside it.
no, nothing's
No, you don't need anything inside it.
Just take any parameter.
Oh, got rid of the wrong thing. Okay. I don't know.
Take your A out. Yeah.
There you
Okay, I'll go back and
go.
mule over that for a while.
And the weird thing is, the other thing we have to do there, like look on 28, it's going to be A dot subtract parentheses B close parentheses dot print fraction open close parentheses. Because all of what you have is just going to return a rational. So you got to put this dot print fraction at the end of it.
And I could have done this an easier way by,
This is fine.
well, it didn't work, but I still don't know. I know you all,
Yeah, because you're
you're trying
trying
to
to.
help me fix it, but I don't understand.
Yeah, well, you can watch the video. I think that'll be helpful. Okay.
Okay, thank you.
No problem. The other thing I wanted to show you all was real quick, the big decimal. I mean, I'm not a big fan of the big decimal. I think it's really annoying.
I think this one was horrible.
Who designed this? I don't know. But anyway, to show you what I did, and it's weird. You have to do things like this. So it's big decimal dot zero. And then I didn't do the whole, here I did it. You have deposit amount dot equals big decimal zero. I mean, that's just the weird stuff you have to do on getting that to work. The point is the big decimal is going to allow us to do accurate financial calculations, okay? But so I think Barbie had asked, will we see that again? On a test, you will not ever see that.
It was so different from the example you did. Like I started out just by replacing the word double.
No,
And then I got a bunch of errors. And so I went back to your, I had looked at it, the link that you sent.
yeah,
I still.
it's all there, but it's just weird. Like when
Thank
when
you,
you're-
Tara and Christina, for asking that last week because that saved me.
So when we're creating the new one, we just have to do the big decimal dot value of stuff, which is crazy. And then what other changes do we have to make? Everything else looks more or less okay in testing it. Yes, that's all I really did differently there. So if you're having trouble on that, you can go back to the video. It's all there. You can look at it and see how.
I ended up having to actually add an else statement in the account because it was like, to me, it was like, oh, this one shouldn't be so hard. You just have to change all the numbers or whatever type thing to the big decimal thing.
Right.
which the book didn't have a reference like list, which that's not smart. And then but like when I tried it, because that second one, the John Blue or whatever, I forget, one of them was negative.
Right.
And so when you did it negative, it pulled up null. And then when you tried to add numbers to it, like add
Oh, it wouldn't work.
balance,
Yeah.
it wouldn't do anything because it was null. So I had to go in and add an else statement to the original account saying
That's weird.
if it's
That
less
might
than
work
0,
for a reason.
then make it 0.
Yeah.
That's what I did too, Kim. I had a problem. I got the null as well.
Yeah, that's weird. I didn't for whatever reason. So who knows?
I just don't understand why it did that.
Yeah.
Like this
Don't spend a lot of time worrying about big decimal. If you turned in homework that had the word big decimal and that kind of looked like a program, you're going to be good because it really annoyed.
I think I just changed his negative to a 0, just so I didn't have to deal with the negative.
That's a
I
program.
just changed his account amount. Yeah.
You'll be a mathematician before this class is over. That's how mathematicians work. Yep, don't change it. That's funny. Okay. If there are other questions of that, just review my code. Again, I don't want to spend a lot of time on that because I want to talk about going forward with this idea of inheritance. Inheritance can be tough for people to get their hands on, get their mind wrapped around it. Okay. So, and the thing in the original video, the override, the ampersand override, I just kind of gloss over it and I should have paid more attention. That's optional. You don't have to do that, but it's a good idea to put it in there because it forces the compiler or it forces Eclipse to make sure you're overriding something that already exists in a superclass. If not, if there's a typo, you can think you're overriding something that you're not. Okay, so it's a good idea. But the whole idea here is that we have superclasses and subclasses. We can have as many layers of these as we want. Okay, the most general of them is going to be at the top. That's the original superclass. Now everything inherits from objects. So objects is the granddaddy of everybody. But when you create your new class, you want the most general thing to be on the top. Okay, so I'm doing an example here of vehicle. I don't know why I named it V. I guess I didn't want to type that day. So we've got public class V, which has a name and a capacity. I'm grasping at straws to make a forced example here. But the idea here is that whatever kind of vehicle you make, what do all vehicles need? And there's probably more than this, but I just came up with name and capacity. Okay, a string for name and a name for the capacity, how much it can carry. Okay. So once you've done that, this is the first class. This is the granddaddy class. So we don't have to do much different. We have to create a constructor here. I'm creating a 2-person constructor, a 2-parameter constructor. Okay, I'm setting in name and capacity and setting those up. Notice I put the little note here, and all this is in the video that I put out. It's a separate video on this. Just so we know about how the constructors work, that when I'm inside the V constructor, I put a note so I know that's happening. Okay. And then I've got to get name, I've got to get capacity, okay? And in this case, let's say that I don't want the user to be able to change. And Barbie, this is what I should have made clearer before. In general, when we're doing a class, you want to put accessors and mutators, but the mutators you may not want. Okay, so we're going to say once you've created an object of type vehicle and it has a name and a capacity, we're not going to let you change it ever at all. So that's what I'm doing here. That you can return it, but you can only change it when it gets created. Okay. And here's that override. We're going to override the toString method. That's the book talks about methods that all objects have. toString is one of them. And it just prints out a string representation. Okay. So all I'm doing here is overriding this. Again, if I take that out, it still works. It's no big deal. But this is what it protects me against. That was not correct. Had too much in there. So what it protects me against is if I would do something like this. It's going to say, whoa, you can't do that. That's not a function in the superclass. So now I know that I'm doing the right thing. So that's where that comes in. So I'm going to override that to say, and this string.format, I'm not sure the book talked about this, but it's kind of cool. It's kind of like the printf, but it just returns a string. It doesn't print it out. So I'm returning the string.format. And then again, I have the %s, has a capacity of %D, and it's setting along name and capacity. Okay, that's all it does. I then have a test for that. This is no inheritance. This is just what this thing does. Okay, so I'm in the V constructor. I've typed in civic and 500. I've done that. So I'm using the get name, the get capacity. Then I'm doing the get string to say civic has a capacity of 500. Okay, all that's just normally what we do for a class. Okay, so now we want to take the vehicle class, and we often say we want to specialize. Okay, you specialize when there are some vehicles that have distinct characteristics you can form into a group. Okay, if we weren't going to add any more member data, you wouldn't have a separate subclass. Okay, so there's got to be something different. So I'm going to make a car class, let's say. Okay, and I really got desperate at this point. So instead of, in addition to the name and the capacity, I just added the number of doors, like anybody cares, but it should show the point. Okay, the real confusing thing I think here for students when we're looking at this is that, again, this is a relationship. A car is a vehicle. Okay, so we're going to call the vehicle constructor with the things that the vehicle cares about, and that's the name and the capacity. So our constructor for the car, since a car is a vehicle, a car has to have a name and a capacity. Okay, I have to send those to the super constructor. It knows, everybody knows their daddy, okay, or their mama. So super points to that. We don't have to care about the name. Okay, but that name is whatever's on the extends here. It's going to be V. Okay, so this is calling V's constructor with the two things that it can call. So then we have to deal with what's left over, the doors. Okay, so I'm going to set this doors equal to doors. Okay, so this int doors I have to deal with in this part of the constructor. Okay, I put the note here that we're in the C constructor. See how that works. I tried putting it up here, it wouldn't let me. The comment's okay, but the first thing that you do in a derived, we say derived when it's inherited from something else, in its constructor is call super. So you can't call super later. Very first thing, I couldn't do a print statement first. Okay, so that's why I put it at the bottom. Okay, so then again, I don't have to worry about the get name and get capacity. Okay, they're already in the vehicle, and a car is a vehicle. I only have to worry about the get doors because that's a vehicle. And if we needed mutators, we have to add those along as well. Okay, and then I'm going to override again the toString. I need a different one here. I'm overriding now the one of the parent, which is overriding the one from the object. I'm just going to add in the doors there, the number of doors. Okay, that's all that's doing. So now when we run this one, we'll see that we start off in the V constructor. Okay, why are we never in the C constructor? That's really weird. Is that not what? Oh, I did that before when I was testing it. It made me insane because when I hit run, I'm still running the V test. I'm not running the C test. Here we go. Here's what I can run. So now I'm just creating a new car with those 3 bits of data. It should run first the V constructor for those two, and then the C constructor, and then it should print out. So let's run that. Yeah, there we go. So we're in the V constructor. You would never print this in your code, really, right? This is for us to see what's happening, okay, or to debug. And now we're in the C constructor, and now we're going to say the Outback has 4 doors and a capacity of 1,000, whatever that is, okay. And in fact, I would actually go back if I'm going to do this. I would do something like this. And again, for me, my ritual, and I'm thinking a lot about rituals in computer programming. My ritual is if I have a code or a message I'm going to get rid of, I'm going to put 3 asterisks in front of it. It doesn't really affect things, except I know when I run it, I know it's a temporary. And I know if this code were 300 lines, I could do a search for ****, and I would know to get rid of that line or comment it out. Okay. Then the other thing I did here, just real quickly, just added another. So in the hierarchy, we have vehicle. Vehicle specializes into car. So you can have a vehicle, and that's fine. The vehicle has a name and a capacity. But if it needs to have doors, then it's going to be a car. Okay. Well, what if it's a boat? Okay, so a boat is a vehicle. A boat is not a car is not a boat. So we have the vehicle on top, it now has two children, okay, that are not related to each other, except they're both related to the parent, okay? So that's what we've got here. So the public class B is going to extend V, okay, so which means I have to have the name and the capacity in my constructor, okay? I'm going to add the length and the number of sails. I like sailboats. I have a sailboat, so I'm a sail guy. But anyway, but if your number is sail 0, then you don't have a sailboat, right? So then the constructor again, now we have the two things we have to have because it's a vehicle, and we add along the two other things that we have. And then first thing we have to do is call the super constructor for the name and capacity, and then deal with the length and number of sails, okay? Then I just added a couple of these for length and get length and get number of sails, okay? And then we can write a test program where we're doing all of these things, okay? So we can, let me see real quick. I hope this is not wasting your time, because I think this is stuff that people are gonna have questions about.
Well, I haven't started the homework for this week, but looking at it, it seems pretty repetitive from the example in the book.
Yes, it is.
So it didn't seem like it was going to be
But
too complicated.
getting the homework done, maybe not, but understanding it, that was the bigger issue. Okay, so you can be more flexible as you move forward. So over here, I can say V vehicles equal to new V with a name, I don't know, Bob, and a capacity of 100. Okay, can do all that. And then I can also, if I want to do a new C, car 1 is equal to new C, which now has to have the name in the same order, capacity of 50, whatever that is. We add number of doors, let's say 4. Okay, I can do B, boat 1 is equal to new B. I'm going to call this an O'Day, because my sailboat's an O'Day. An O'Day, its capacity, which I don't know what capacity is. Let's say 300, and it has to have a length. I think mine's 20 feet. How many sails do I have? I have 2 sails. Okay. So we can put them all in the same program. And again, this assumes they're all in the same directory or in the same project or whatever. The same directory is enough. Okay. And then we can go ahead and run any of those. We can do a 2-string on it. We can do whatever we want to do. But that's the basic idea of how the inheritance works. Okay. Other questions about any of that stuff? I know you probably haven't gotten to a lot of homework, but I wanted to get the theoretical framework out there.
Well, I hadn't worked on actually doing the problem yet, but I'd put in the two programs that it used from the chapter. Like I went through the lecture and the chapter already, but so it has the 2 that it uses for in the chapter are like the commission employee, and then like if you were doing an inheritance, it would be like the base commission employee is a commission employee, right?
And that's super wordy and confusing, that example, but yes.
But then it's asking in 14 to do employee, right? So
Do super class, yes.
a new super class for that goes above
Yes.
commission employee.
That commission
So-
employee would derive from that, commission plus would derive from that. So you can have 3 levels.
So, yeah, and it's basically about like thinking about what inherits from where,
Yes.
and sorry, my children are acting out. And so what inherits from where and being able to move all those things around, right?
Yes, and
So
on
you have-
that, the constructor, so the base commissioned employee, whatever it is, that bottom one, will have to call the constructor first for the superclass, for the things that are in the superclass, and then of the commissioned employee for the things that are there, and then finally do its own stuff. So there'll be layers of that. Okay.
So it's gonna need to call from the top, not from the,
I think that now that I said that, I'm not sure. test it and see. I think it has to go to the super class first
Yeah, it
because
said that you have to test out both after, to make sure they're still doing
Right.
what they're supposed to do once you
Yes.
change them.
yeah,
But I
makes
haven't
sense.
done all that yet. I just was
Yeah, but I think
looking
you
through
do
it and
super-
making diagrams and stuff.
Yes. But, well, no, wait, that's not correct. Because super only has meaning for one. I think that
Right.
the middle one's just gonna call, so the bottom one would call super on everything that the super and the other super does. The grand
Okay.
super, so yeah, that you do, so you're just gonna have one call per.
So if it calls from the parent class, it is automatically calling from the super class too.
Yes, yes,
Okay,
yes.
that's what I thought.
Yep.
And then I wanted to ask about, because it said to call it employee, but we've already had something that we called employee.
Yeah.
Can we call it like employee hierarchy? That's like the name of the problem.
You can, or I
Okay.
just put a one on the end, employee one, but whatever.
Yeah, I just don't want to get them all confused.
I don't blame him. The other thing I didn't say that we need to talk about real quick is the idea of protected. Okay, remember protected is
Yeah.
not public, it's not private. And what it means really is that if we're in this C.Java, okay, and I wanted to, did I change mine? That really shouldn't work. Oh, I changed mine. Yeah, right here. If this were, and I just glossed over that. If these were private, and they may need to be for other reasons. If they're private, when I go here to overload this, look what happened, right? I get a problem. I can't do that. I would have to say, I would have to call the constructor on, what would it be, a this dot get name?
Well, on the, like when you put in those programs that are in the chapter, I mean, it explains it a little bit, but it's easier when you have the code in to see,
Yes,
because it shows how there's an error and then it tells you have to go back into commission employee and change those original things to protected.
yes. And my
Um,
preference is to do that. I mean, I think protected makes a lot of sense. But what protected means is that derived classes can get to the private data, which makes sense. We're saying a car is a vehicle, but if you make it private in the vehicle, a car can't get to its own name without going through those constructors or through those accessors and mutators. That doesn't make sense to me in most cases. So I think that the better option here is to not do that, to undo what I just did. I won't undo it, but basically over here, make these protected.
Well, doesn't it make it so it can access it, but not change it? So like private, it can access it only if you have an accessor
Yes,
function.
yes.
But so does protected make it more easy to access?
Yeah, protected means it's what protected does in this case is that V and C and B, the name and capacity are just local to all of them. It's like they were in there, no different. Which means
Okay.
with protected, I could, if I wanted to do, down here, name is equal to Bob. Why is it not okay? Maybe it's not okay. Oh, because have you got that yet? Unreachable code. It's because you can't ever get there because we return before we get there. So let me move it up to here. That's a bad place to put it probably. Yeah. So even though I'm in C, I have direct manipulation access to everything in the subclass or in the superclass because it was protected. So protected doesn't protect anything really. What protected does, it means if I were in another class that had nothing, say I'm in the account class and I create a new object of type C or B or B, then I can't get to name and capacity directly. Where if they were public, I could get to them from anywhere directly. But they're protected from the outside world, but you're saying that they have the same level of access in V and C and B in any children or subclasses.
Okay. I was thinking it was like you could get to it, but you couldn't change it.
That would make sense with the name protected, but that's not what protected means.
Okay.
In fact, what it does, it removes all protections from subclasses,
Okay.
but it's still protected from the outside world. So it's not public, but it is
Protected
public.
within all levels of
Yes.
its own thing.
There
Okay.
or below, because I mean, if you have the 3 layer, then something
Right.
that's declared in the middle layer as protected would be available in the bottom layer. Okay.
Mhm.
But it doesn't go the other way. Okay. So
Okay.
class V doesn't know about doors and can't ever know about doors,
Okay.
right? Because it doesn't have doors. So
Yeah, it doesn't need to access it.
no, a car is a vehicle is not a car
Mhm.
in that sense. Okay. So I think that's I think that'll help if you watch this video again, if you need to. And I did the other example where I talked about this more, but that can't be hit on enough because that's going to be where we're going to get some trouble. The next chapter, we're going to talk about polymorphism and interfaces, which are going to be on the same idea of inheritance. So inheritance is a big topic. So it's really, it's worth taking the time this week to make sure you really understand how inheritance works and why we're doing what we're doing. Okay. So if you have questions now, feel free to ask them. If you have questions coming up, make sure you let me know. Okay. And I'll either, this week, it will probably be easier for me if I get questions to release a video than it is to do a Zoom, just given the nature of what my life's going to be like. But I don't have a problem doing that. Okay. And remember also going forward, just like before, if there's any problem from the homework that you want me to do a video on, I'll just do it. I'll probably do it anyway, but sometimes I don't do them all. The programs now are getting more complicated, so we're going to see fewer of them. There'll be 1 or 2 per week instead of 4 or 5 sometimes, but they'll be a little more difficult. Okay. What you're also going to see in comments from me, and I won't take off points, at least not at first, certainly. If your code's not well organized, if it's hard for me to grade, I'm gonna let you know that. That's valuable feedback. It doesn't mean it's wrong. If it works, and you're probably gonna get most of the points. But if yours is laid out in a way that is really hard for me to understand, when I look at your code, I should be able to say, oh, boom, 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 there's what you've got. Okay, because if you're doing that, then you're thinking about it in an efficient manner, which is good for the exam and good for programming. Okay. If it looks like, if your programs look like a ransom note that you've pulled together from 15 different things, then you're not there yet. Okay. Even if you get it to work, it's not smooth. It doesn't look good. It's a difference between a carpenter making a cabinet and Lord help us, me making a cabinet. I may have a cabinet with a door you can open up. You would know real clearly that it was not made by a professional. And I don't expect it to be professional. Don't hear me saying that. But I want to give that feedback that it should be really clear what your program's doing to anybody who looks at it. Okay. And if you don't know if it's clear yet, then you may not understand it enough. So again, it's not a big deal you're not there, but I want you to get there, if that makes any sense. Okay.
Do you like more comments? Because I feel like I've been putting more and more comments every time.
No, I think that's okay. I think that I like more comments better than no comments.
Because I even put in a couple of comments on my last one were like, I couldn't get it to do this, but I did this instead.
In a class that you're taking, that's perfect. I don't have a problem
Okay.
thinking that. I had one student, C++, bless her heart, she would write like novellas in the comments explaining her life history as it related to this program. It's kind of like if you look up a recipe online, you have to read the whole life history. Yeah, that's how our programs work. So yeah, at this point, you probably can't comment too much unless I just can't find your code. But, that's why, again, it's ritual. When I create a class, I try to do the same thing. I put the comments in. I do the same things in the same order. I call things the same thing, just because it's less mental overhead. The more practice, it just becomes easy over time. So yeah, but if you're getting too many comments, I'll let you know, but I don't think anyone's getting too many comments yet. Okay. What else? One thing that I'd forgotten about until I was looking at the syllabus is remember that there's a presentation as part of this class. And in talking with Heather, you've got the overall assignment among all the classes of doing the resources for the open learning thing or whatever that you probably know more about than I do.
The
But-
portfolio we have to do, you mean?
Yes. So we need to incorporate that into this class. Okay. And I think we're at the point, and I don't do this enough. So if you have me for algorithms, make sure you remind me to focus on this. I tend to focus on the CS element of it and not the teaching element, because I don't teach high school kids or elementary school kids or whatever. But that's a focus of this whole program. That's that's the main reason we're here, to be able to teach the kids. So I'll probably throw a few homework assignments in that relate to those things, just so you can get some of those out of the way, get some feedback from me. I don't know how to teach your kids, so you have to teach me that part. But I can tell you if you're making, if it's making sense what you're doing from a technical point of view. And our presentation, I think, will be on some learning, and this is all very wishy-washy in my head right now, and I would accept feedback now or later. But I'm thinking the project should be a lesson that you could do that's a little more, maybe a multi-lesson set to teach students how to do something with Java. Okay, and that gets tough because what we've seen so far, up to now, we're learning the basic skill set of Java. That takes a while. You often see things like, oh, we're going to do a 1 hour programming course. You're not going to do much in 1 hour, right? We've seen for your second programming language now, there's too much overhead. But if there's a way we can think of aspects of that, like teaching for loops to whatever age group you teach, or teaching whatever to whatever, the presentation is going to focus on that. Okay, and you'll be happy to know I had a conversation with Heather also about the aims of the program. And I was really concerned about the algorithms class, which is the next one. No, it's the last one you take, I think. Algorithms at the undergraduate level requires calculus, and there are people who would flatline. It's just not your experience. Some of you would do fine, some of you would not. So I was really concerned about that. And I got from Heather that we're not trying to match the undergraduate courses exactly. So I have the ability to find a textbook that tones down the math. So we're going to that course in particular is going to focus more on how we're going to teach these algorithms, and the algorithms at a more high level, not at the super mathematical calculus level. Okay, so I think that should make most of you happy. If you like calculus, then maybe you won't be happy, but I can point you to some other things if you want to do that. But yeah, I sometimes forget these courses have the same names of courses at the undergrad level, so I just assume that this, and that's not always correct. Again, I wouldn't have changed anything in this course up until now, because we just got to get to this level. But from here out, we need to think about why you're here and think about strategies for teaching to do that.
So when you say the presentation, like, do you want us to actually present it, or it's just we're creating a document that will be submitted?
It'll be both. I think it'll be a lesson plan, and then the presentation, I'll probably just have you video yourself. You can use Zoom for that, and then submit it rather than try to do it live, because there's so many of us that would be hard to schedule all that. I'll put them out there so everybody can view them. What's that?
We've done lesson plans before and submitted, but we haven't ever videoed ourselves doing it. So how long would you want that video?
Here's a thought. And again, I don't teach like you teach. I teach different in a different world. What if we pair up and you have one of you be the student and the other one go through the lesson? Would that be helpful? You look stunned by that. Was good stunned or bad stunned? Because to me,
Well, I think
provide a
part of the
lesson
thing
plan.
with that is that some of us teach at different levels.
But you can
So,
select. I'm not going to tell you who to pick.
well, right. I'm just saying, like, I do high school. So somebody who doesn't teach at the high school level, if I were to do that, they might be like, what are you doing?
Yeah.
I mean,
Yeah, so we'll try to get it where we're not picking. But if you have a guinea pig, per se, that you're teaching the lesson to, it may be easier than just trying to describe. It's either going to be, you're going to describe how you would teach it, or you're going to teach it.
So
Yeah.
it could be like it could either be as if you're teaching the lesson, or it could be as if you are teaching a teacher how to
Yes.
do this lesson. Okay.
100%. So I don't know.
Which that would probably work well with the OER, because we could actually put the video in those open ed resources.
Oh, of explaining how to teach it?
Yeah, to explain how to teach this.
Yeah, we'll just
That
keep it
could
that
be
way.
our artifact
Yeah, that's fine.
or part of it.
Again, when it comes to these aspects of the class, I am totally open to suggestion. This is your world, not
Okay.
mine. The CS stuff, then we may argue about, but I'm not going to argue about the teaching aspect of it. If that's what makes more sense for your portfolios, that's what we'll do. Somebody send me an email if I don't put that up in the next week. I'll go ahead and make it, even that's good to do at the end. I'll go ahead and put it up as an assignment now so we can be working on it. And don't laugh when my language is not precise, because you guys have your own language as we do, as everyone does. So I'll say, do the thing. And you're like, there's no such thing. It's called this. Yeah, whatever. Let me know and I'll change it. I have no pride.
Dr. Frazier,
Yes.
when we're doing these, and there could be a variety of ways to teach it. I'm elementary school, but if there's a program that I haven't yet, but I'll be incorporating, like Scratch, for instance.
Yes.
Can I integrate some of that in there or because I would never use Python or Java in the elementary classroom.
Yeah. It's a good question.
It's too hard. They're going to have fun with it in order to.
These are times I'm
Could
right.
you just do basic things like
Goatee's
just
very
having them print stuff? Like in Java, you could have them use the
Well,
different types of
I mean,
print
I
statements.
could just for this lesson, but it's not something that I have searched and found some things this summer that I think, yes, this will be, this will work in the elementary classroom. I mean, I could do things like this, but
Yeah, I know what you're saying. I know what you're saying. And the things that your portfolio is not going to include anything like this, right? Because it's all going to be stuff.
well, so far it hasn't. I've really geared it toward elementary. I mean, I've used certain aspects.
Yeah.
But I truly, and I have used, like last semester I used Python and I could use Java, but I'm thinking, work smarter, not harder. Can I make something that I would actually use now? Because things that I have turned in the past, lesson plans, I probably wouldn't. I mean, we don't have an IT. They're not going to a computer science class.
Gotcha.
And I have all these objectives in math, science, history, and language arts. So I have to incorporate it in a way that is fun, is engaging, and that they're not super confused.
I think that makes sense. So send me an email so I can think about it more fully I told you my dog kept me up last night. It's not a good time for me to make life decisions. I'll also talk to Heather to make sure that I don't need to keep it related to Java somehow. If it has to be Java related, then it'll have to be, and you just won't be able to use it later. But I see your point. I think certainly anybody not elementary school should be able to use Java. But elementary school could certainly be an issue where something like
the Scratch program does integrate things, from Python, Java, and I'm told C++. I'm not familiar with that, so I wouldn't know. But
Right.
I mean.
Yeah, Java's over the head of most elementary school kids for sure. So send me an email, and I'll run it by Heather, and we'll come to a decision. But yeah, it does make sense.
Yeah, the challenging thing, and I guess it's the way I see it is it's the whole reason for having our cohort is that, like Barbie said, they don't have computer science classes, but there are computer science standards for all the way K through 12.
Right.
So while the elementary and even some of the middle are not getting computer science classes, they do have to learn it. So the classroom teachers have to incorporate. And so the way I see it is they have to start learning how to incorporate not necessarily even all of the programming part, but just starting to incorporate the language so that the students understand, what an attribute is or what certain words mean, even if they don't know how to program yet.
I think that makes a lot of sense. I think that you hit upon a very important part. I really like teaching the freshman programming course because a lot of people that would be good hate it because they're tired of it, and other people that are not programmers are not good and they don't use the right language. It's important we call things what they're really called in computer science. So that makes sense. If anybody has those standards, could someone send me an email to them? Because I don't know that. Yeah, I don't. One of two
I
things.
think
on all of
Heather put them up. I don't know if you have access
Oh, on
to
the
the
Moodle.
CS cohort. She
Yeah, let me
put-
take a look. I can look there. Yeah, that makes sense. I think always the communication, because of the pandemic, has not been as good between Heather and Karen and I as it could have been. We had one meeting before the pandemic when we planned all this out, and I was under the impression that we were trying to give you guys, in essence, a shortened computer science curriculum, and that is just not, that's not the goal at all. And I'm sure it's my mistake in not picking up on that, but so I'm changing my focus a little bit on that to try to move toward that goal and to get you able to teach these things in your classrooms effectively. So yeah, that will, and that it has, it's radically changed how it's going to teach the algorithms course, because you don't need the CS algorithms course. Most of you don't, wouldn't like it. It would be hard to get through. Looking back at the discrete math, I don't know. I didn't pick the curriculum, so I don't know discrete math was the best choice to have as a course, because I think
It's required.
it has to be
So
discrete.
like, yeah, to be able to be certified to teach computer science.
Okay.
Like if I had to go online, because I had this like whole thing with my licensure specialist in my district.
Yep.
So the 6 classes that we're doing exactly meet those criteria. So you have to
Gotcha.
have discrete math, you have to have the algorithms, you have to have data, what's the data
Data structure.
structures, the
And 2
intro
languages.
course, and then 2 programming languages.
That makes
So that's
perfect.
exactly what they've designed it to be. So discrete was something that we had to have.
Okay.
Well,
But
I think it was helpful as far as, thinking about how you set up your programs.
I think it's good, but I think that for especially probably those that don't teach high school, the math could have been a little steep. I don't know how much math that elementary school teachers tend to have. I assume it's not a ton because you're taking other things. But I guess what I didn't, and I'm going to blame the pandemic because Heather's totally on top of things. I'm not. So if there's a fault, probably mine. But I should have had, if there's a list of topics that course was supposed to cover, I should have had that. And I didn't have that. So
I don't know if it doesn't go into that. Like, so Jude just posted the link to that. So like
Oh.
once we finish these 6 classes, we are all like, we can add the endorsement to teach computer science on our licenses. And
Gotcha.
so without taking the praxis, because I talked to the teacher at my school who is certified in computer science, although he just
Right.
left this at the end of the year.
Right.
And he was like, why don't you just take the praxis? And I was like, yeah, because I totally passed that.
You have
Like,
to learn it first.
so, and plus like this way, A, it gives me recertification points.
Yeah.
And then B, it's free. And C, like if I'm going to teach this, I really need to do this material.
Right.
So I just think it's the better option anyway.
Right.
So I don't think it tells you what you need to do in it. It's just a general discrete math class.
But I really need, I was surprised at the range of mathematical skills, because I assumed I was getting all high school math teachers that teach calculus every year.
Well, I've been surprised at that in general. No offense to anyone who's not, but
Yeah, no,
Well,
and-
I have mentioned that before, the criteria, just, for getting into the program.
Mhm.
I'm sure they'll take a
Well,
look
I
at
mean,
that later.
they need people at the elementary level to,
Well,
introduce
I know,
it and
but I think
whatever,
it
but-
could be structured a little bit different, because I went into this in hopes of, I saw all those computer science objectives. It's been around since 2016 with CS for All with Obama. 2017, we got all the objectives, and we were just putting it in our talent ed and not really doing anything with it. I mean,
it makes sense. But I think
our
these are the
kids
wrong courses
can-
for you. That's my feel, that these are the wrong courses for you to be taking.
yes, yes.
And I can't do anything about
Yes
that.
and no. I want to say, when I found the Scratch program,
Yep.
and I found CS First
Yep.
to teach elementary teachers how to infuse that into the classroom
Yep.
is probably what I should have had all along.
And that's what these courses should be focusing on.
Because it was
There's no
like
mechanism
a
for that.
beginner. Yeah, this is really advanced for me. I've struggled with it.
Yeah,
But
yeah, and it's nothing more than that's not what you did in college. As undergrad.
my hopes are not to take this to middle school or high school. It's to
That makes
make
sense.
sure
See, like, I
elementary
could-
classroom teachers can.
My district is already on me. They wanted me to this coming year to teach it, and I was like, Actually, they wanted me to teach it this past year, and I was like, I've had one class, and there's a pandemic. No, thank you.
Exactly. Yeah.
Right.
But I'm technically not certified, so I think they're kind of waiting. But I think once the end of this year comes, they're gonna pounce on me. And see, I have 5 high schools in my district, and they were talking about me traveling between 3 of them, and I was like,
Mm,
I don't even know if that's what I really want to do. Like, I would be fine with staying at my school and teaching like that's what my colleague did. He stayed, he was strictly at our high school, and he's in our math department, and he teaches, like, he had like 4 math courses, and then he had 2 computer science courses. And I'm like, I'd be okay with that. I wouldn't even mind maybe going over to this other high school, 1 block or something. That wouldn't be the end of the world. But heck, if I have to travel to 3 schools, but that's what this, I think, is preparing us for.
Right.
Is technically, Barbie, you could do that
there you
when
go.
you're done with it.
Well, my hopes are still, and I think I can do that with Scratch and CS first, or to bring it to the elementary classroom so that teachers
And
such
someone
as
should be doing
myself wouldn't be overwhelmed, because there's
Yeah.
videos with it and it kind of takes you step by step. We're just going to be making storyboards. Yes, we're going to be using loops and we're going to be using if then statements, but they might not really know what that is.
Well, I've taught Scratch before. I've
and-
taught there was some Tennessee
Yeah.
programming academy I taught in a couple of years back that had kids as little as like 10-year-olds. And
Well,
we did-
K through second can use Scratch
Yeah.
Junior,
Yeah.
but those are things that could have been beneficial to me, because when I saw it, I thought, yes, I need to learn all this, because we were just playing around with drones
Yeah.
and getting robots to move, but we were not creating, we were consuming.
yeah, and that
It had already been built for us. We were just hitting arrows. We
But
weren't.
the problem with that, and this is a non-political statement because it's true of all politicians, they're dumb when it comes to education, and they're dumb when it comes to technology. They're really dumb when it comes to technology education. I mean, I've taught before in the Upward Bound program when I was at Tuskegee, and they get all this money from the government and like to teach high school kids, first generation high school kids. So what are we going to teach them? Oh, let's get them 3D printers. So teach a class with 3D printers. I'm like, what is that? What does that even mean? What am I doing? Oh, just teach them something with 3D printers.
But we have some in our county that haven't
Oh,
even been
okay.
turned on
It's
because they
ridiculous.
don't know how to use them.
If you want more computer scientists because the world needs them, first off, teach them math.
Mhm.
Job one. If they don't know math, they're not going to be good programmers.
Well, part of the problem with that is some of the things that they need in the math classrooms are not being taught that help with computer science. Like, I've taught geometry for 14 years.
Yep.
They don't do truth. We don't do, I've never taught truth tables.
That's
Ever.
crazy.
And that's,
Modulo. Do you ever teach modulo?
nope,
Why
Because
why
we're
not?
teaching to the test.
because
There's
it's
certain
not on the
objectives.
SOL.
And what
That's-
what choice do you have? Now I don't blame the teachers at all. Your job is to get good SOL scores or your SOL. Then that's a whole other thing. So I understand that, but that's again politicians getting involved when they don't need to be, because it's just stupid. I mean, it is stupid. And then they get to the college level, and we're like, all that stuff you've done for the last 12 years, you don't need any of that. None of it makes any sense. Because I don't ever give multiple choice tests, and students are used to doing multiple choice tests because that's what they do in high school, and it's all just. And I know you guys, I know other high school teachers that could really do so much better if they just leave them alone and quit testing all the time. But no one listens to me. But,
Well, assessment is good. I mean, we have to, whether it's
Mm-hmm.
formative or summative, we have to know if we've been effective. I mean,
yeah, I can understand, but I know when my
but it does
nephew went
take
to-
away,
it does, and it leaves no freedom for the teachers to do.
and it stresses us out when we have like to interject. I'm glad I found CS first, because I thought teachers are gonna just see this as, oh, this is something else I have to teach.
Oh, yeah. And
And,
I know a lot of teachers that are leaving the profession because they just can't take it anymore. That's too bad. I know some really good teachers.
And if
that are
they
doing
took,
other
if we
things.
didn't have that SOL pressure, we could all maybe be computer science teachers in 3 to 5 years, you know?
There you go.
Maybe we would be learning it with our students at whatever level that we're in. But because we have all those objectives in the back of our head, that's what we're gonna spend most of our time with.
It really, I mean, we're all educators, but it always amazes me how much we don't understand each other. Because, and I see it with the freshmen, what they expect and what I do in my classroom, and not me, all college professors. It's so different from what you high school people do, that it's jarring for the students that they've been taught this one way, you know, and they get to college, there's no SOLs, there's no achievement test. We don't care. Can you do the work or not? I mean, that's what it amounts to. And we have no problem failing people. I don't like failing people. In fact, I would say they fail themselves. But I know that a lot of the high school teachers I know, you can't fail too many people or they're on you. You fail as a teacher if your kids fail. And that's just,
Well, just warning you, the freshmen coming in may be even worse because with the hybrid learning this year, the cheating and the crazy, it's ugh, the stories. The
I
stories.
can only imagine. And I've got
So
my whole schedule.
just be
is all
prepared.
freshmen. And they don't believe me when I tell them, because I've added a very specific lecture that, you know, because I've worked enough, I've taught high school teachers before. I kind of know what's going on, not a lot, but a little bit. I tell them, here are the differences, here are things, how things work. For example, I would never tell a student they're doing, if they fail a test, okay, you can come talk to me. I don't talk to them. And I think most of you would talk to your students because you kind of have to say, well, what's going on? We need to work on this one.
Or we talk to the parents.
Yeah, none of that happens in college. And it really some students have a real hard time making that transition. And we need to smooth that out somehow. I don't know how, but it's helped me. I think that at least I know more where they're coming from. They still don't believe me. I mean, I don't know why, but they don't. You know, kids, you know, you got them. They're all about half crazed these days anyway. But yeah, the Zoom hadn't helped anybody. That is for sure. Yeah, but I don't know. No one's gonna listen to us unless we get elected to something, which good Lord, I don't want that to happen to any of us. That's a fate worse than death, I would say, but don't know. But we will try and keep me on topic on that because I'll want to teach the computer science stuff. That's what I know. It's what gets me excited. I don't know the high school teaching stuff, so, but yeah, let's try in the rest of this class and definitely the algorithms class to make sure we're focusing on your task is not to become a programmer. Your task is to teach kids to program or to teach kids to whatever. So, and again, what we've done up to now in this class, I wouldn't have changed that no matter what, because we need this basic level. But after this next chapter, especially, we're going to be more into that. We can start thinking about how we can incorporate it into our classroom and see how it goes. Do you know, Barbie, if there are any other elementary school teachers, or are you the sole?
Dana is an elementary school teacher.
I work primarily in elementary.
Okay.
Oh, I didn't know that, Jude.
You
I
don't
think
like
there's
elementary.
somebody else that's elementary,
Okay.
but
I teach middle, but I just interviewed for an elementary job. So we'll see what happens.
oh, librarian, good for you. I wondered about that.
I
That
did, yeah.
principal is awesome.
Yeah, and your principal was in the interview too.
Yeah, yeah. Yeah, they all interview, right? I guess.
Yeah,
all
they always
come.
have to have somebody else with
Oh.
them,
Okay, well, back
like
in the
another
day,
administrator.
it was like all principals came to the interview. I didn't know if they
It was
did it
just the two
different
of them.
for a transfer.
That's enough, that's it.
Mhm.
It's just such a different world, so strange. But anyway, well, we probably ought to get off here. But
Well, can I give some feedback based on what you said in your lecture?
Yes.
You said that if anyone liked the idea of the 3 individual hours
Yes.
for the test to mention, and I like that idea.
yeah, I think that unless there's there's no harm in doing that, because if you want to take it all together, take it all together. You know, so I see that's a no-brainer. I don't see how anyone. If you have an objection, let me know. But I can't imagine why anybody would complain. So again, if you didn't watch that video yet, basically what that means, the question was, what if you don't have 3 hours at one time to be able to take the exam? I know you've got kids and lives and all that stuff. So I'm guessing there will be 3 problems on the final exam as well, 3 programs. And I'll make them, in essence, 3 separate exams, each of which has a 1 hour time. Now, what that doesn't give you, the downside to that, is you can't steal from one for the other. So I guess that's the downside. But the upside, again, you're not going to spend 2.5 hours on one program. And some students do that. They get so obsessed with getting one exactly right. So it's going to require some discipline on your part, and it's not without some cost. But I think overall, I think it'll be better. And then if you just want to, I mean, 3 hours is a long time to take a freaking exam. I mean, that's a long stretch. So maybe if you could take an hour on a Friday and then take an hour on a Saturday, an hour on a Sunday. I mean, that may work better for everybody.
Especially since it's all programming. I know before we had a bunch of multiple choice
Mhm.
questions and then like one program, but yeah, 3 programs.
Oh, because that must be from Karen, because you've never had a multiple choice of me, because I don't ever.
Oh, yes.
I have a moral.
It helps
obligation.
point wise, but.
Because a multiple choice gives you a 25% chance of getting credit when you don't know anything, and it gives you a not perfect chance of getting it right even if you know, because you've got to make them a little bit tricky or they're just stupid easy. Yeah, not a fan. But anyway. Yeah, I think that's a done deal in my book, unless someone convinces me otherwise. I think that will be a better way for those of you who do have lives to attend to.
So will we still be progressing through the chapters, and you'll just say, like, will there be a project with each chapter of how you would
No, probably not. We'll
incorporate it?
this is still new in my mind, so I haven't quite worked it out yet. The project will certainly be something you're going to do for a teaching kind of a lesson plan. We may do another one if there's time, but we're going to keep doing one chapter a week. Now, I was feeling kind of bad because that's slower than they would go in the undergrad classes. But again, given the nature of this class, that's perfectly okay. I feel better about that. So yeah, there'll be more information on that later. And I was going to mention that in the video that I put out Sunday or Monday, but I didn't. So wanted to put it out here, and we'll go from there. But yeah, so we'll figure it all out. And again, there'll be fewer programs due each week because they're a little more complicated. And let's go from there. See what we can do. Okay. Any other final shots on our longest office hour ever? It's okay.
I am gonna redo that program and resubmit.
That's perfectly okay.
Okay.
The big thing I don't want is, and again, don't take time away from this week to do that. You know, so
Sure.
try to be quick on
Sure.
it. That's the problem students can get.
Well,
by.
I think I see what I did, so it should be a fairly easy fix.
Okay, good. And again, for this week's stuff, inheritance is important. We're gonna deal with it a lot. So try to make sure that you understand not just how to do it, not just how to copy it from, an example from the book and rework it, but you understand what we're doing, why we're doing it. Okay. And if you have questions, let me know. Okay. Okay, that's all I've got then. You guys have a good week, and I'll have another video on Monday. Sure. Okay, talk to you later.
Thank you.
Hope your dad does okay on his procedure.
Okay, should be good, hopefully. But you never know. These are always scary. My dad's 80, so 80 is scary. But anyway. Okay, talk to you guys later then.
Bye.
Thank
Thank
you.
you.
Bye-bye.